Hey everybody, this is Larry. This is me going over Q2 of the weekly contest 217. Find the most competitive subsequence. Let me make this slightly bigger. Um, so for this one, you're basically I don't know what's with all the or the uh, or the language with competitive or whatever, but basically being the most competitive means the earliest, the lexicographically smallest subsequence, which means that it appears the earliest if you had sort them in any order and so forth. Yeah, hit the like button, hit the subscribe button, join me on Discord. But yeah, but this one, it took me a long time during the contest, so I think it was kind of tricky. It took me about 29 minutes. And I mean, other people took a while, but that's because they solved two other problems first. Um, so for me, the tricky part about this one is just trying to find the invariant about the problem. I think I had some idea about greedy, and that's basically the idea. And this problem is greedy, and there's some intuition that around that greedy is that you want to be as you you basically as much as you want to get you can get away with, you get the earliest numbers possible. And there are a couple of ways to implement it. The way that I did it is with just through a queue or a deck. The idea is that okay, for each sequence, let me show this as an example. For each sequence, we basically, well, if we could put it into the queue, we put it in the queue because it's less than yeah. Though I had it off by one here, that's why I have this. But the idea is that okay, let's say you process the 2, you put it into the queue, you process the 4, you put it in the queue, you process the 3. Well, the question you ask yourself is okay, you put this 3, well, you know that 2 3 dot 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 is comes earlier than 2 4 3 dot dot dot, right? And looking at the last element, um and then your question is, can we replace this sequence with this sequence, right? And the answer is yes, if and only if there are enough digits left, right? Because if you have, like, for example, if you have another case, or maybe just the same case, and let's see, and k is equal to 8, then the answer is no, right? Because if k is equal to 8, k plus something equals 8. Anyway, if k is equal to 8, then you run out of digits, right? Because the entire number is 8, so then you have to keep this, right? Otherwise, let's say k is 7. Well, if k is 7, then this is always going to come before this, and we get to remove one digit, so we might as well remove the 4. So that's basically the invariant that comes up in the loop, and that's pretty much it, really. So as soon as you could find out that this invariant, you're able to solve this, and it's just an implementation problem, which it's still tricky. It took me half an hour. I don't know, but yeah. So it's while each item, or so we look at the queue at the bottom, at the end of the queue, because now we're pushing the 3, right? For example, while the item has a queue, we look at the last item, and if the last item is bigger than this item, and we still have um, and we still have room to go. This is how you could represent this math. Try it at home. But as long as we still have elements left to kind of fit k elements, we pop this off. Otherwise, we just append to this. And I think in theory, I should have just done if length during the contest. I mean, this is a little bit. This is not contest code, so is a little bit sorry, this is contest code, so some of it is a little bit shaky, and instead of proving that invariant that I just did here, I just added this where if it is longer than k, I pop it, because that means that let's say if you have let's say k is 1, I before that I would just keep on appending, because that's the way that I did it. But that's okay, because if you keep on appending, it only add to the end, and you only care about the first k elements anyway. But that's the basic idea. This is my contest code. It's not as clean as it usually is, or like it doesn't have that proof, so it's a little bit weird looking. But yeah, that's the invariant, and it took a long time. So feel free to fast forward my contest, whatever. But you can watch it if you like to learn to see or whatever during the contest. Now. Hmm. 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 Here's this one. Nope. So now and left. Almost the one button. Oh. I'm missing something really dumb on this one. This is Larry, come on. Come on. Ooh. Oh, that's not even close. Oh, for some reason I thought they're 1 to 10. Of course they're not 1 to. Oh my. Wow, I totally misread this one. How do I do this then? Everyone knows how this one except for me, apparently. Let me skip ahead. I need to do this. It's just sorting. How did I misread this? Mm. That's 2. Start with this. Mm. Oops. Mm. Oops. Hmm. That's not right. How am I so bad at this? No, that's not right. Wow, I just have no idea. This is just one of those really weird mind blanks. I think this is right. This is an extra one. Oh my. Let's see. Oh, that's just popping back. Wow. Oh, that took too long. Hey everybody. Yeah, thanks for watching. Let me know what you think about this problem set. That was a very tough problem set. And this problem as well. So hit the like button, hit the subscribe button, join me in Discord. Let me know what you think. Let me know your questions, and I will see y'all next problem. Bye bye.